Hey everyone, welcome to my channel. In this video, we'll be talking about another common yet quite important coding challenge, which is the sum of two linked lists. Let's have a look at the problem statement. Okay, this is the problem that we have at hand. We have to add two linked lists. Given the head pointers of two linked lists, where each link represents an integer number and each node of that linked list represents a digit of that integer. We have to add the two numbers and return the sum as a linked list itself. There's also a note given here that says the first node in the list represents the least significant digit. So what that means is, if I talk about the first linked list in the given example, 2169, if I have to write this as a mathematical number, I'll be writing 9612, where 2 is my least significant digit and 9 is my most significant digit. So the order of linked list is reversed. And similarly, if I have to write the second linked list, which is 755, so it becomes 557. Now I can just add these two numbers using simple mathematics and I'll get result 7 plus 2 becomes 9, 5 plus 1 6, 6 plus 5 is 11. So I'll write 1 here and 1 goes to carry. Then 9 plus 1 becomes 10. I'll write 0 here and then 1 which is in carry comes down and I get the answer as 10169. Now I can represent this answer as a linked list 10169 and my linked list becomes 96101. So this is what we have to do. And we'll of course be using linked list to solve this problem. So before we start writing code, let's spend a few minutes to understand what linked lists are. So a linked list is a list of linked nodes. Like I have here 4 nodes that are linked to each other. To understand how this linking works, let's have a closer look at a single node. So each node in a linked list is divided into two elements. One is the data element. For example, here we are storing a numeric value, which is 7. That's one part of node. The other part of node is a pointer or a reference to the next node. Like this can refer to node A or node B or any node in the given linked list. Now, when these are chained together, we get a linked list. There are a few more terminologies that we should know. For example, the first node in a linked list is called a head, and the last node in a linked list is called a tail. How do you detect a tail is very simple. Linked lists are null terminated. So if any node in a linked list is pointing to null, that means that is the last node of that linked list, and linked list ends there. There's nothing after that. So we can have values 1, 2, 3, 4 here. And after 4, the linked list is ending. So that's just, a 1-minute concept of what linked lists are. Let's utilize this now to solve the problem at hand. Okay, it's time we coded the solution. In the previous tic-tac-toe video, we used JavaScript to code our solution. But these DSA problems and interview questions are technology agnostic. So it's on us which language do we want to select. So for this linked list problem, let's go with, let's say we go with Python. So we create a main.py file. And I'll just start with the hello world. And let's just make sure that the Python compiler is in place. So I'll just run it using the Python 3 command. And I get hello from Python in my terminal. That means the compiler is in place and my basic script is running. To solve the linked list problem, I'll have to first create the node class and the linked list class to save the data structure. So let's start with that. Let's say I have a class list node, and I'll create a constructor. In which I'll take one data argument. Oh, it will be def. And in that, I'll just set self.data equals data which is to save the numeric value. And then I'll also set self.next to none. So this next is our pointer, which is initially set to none, but it can point to any other node in the linked list, which we'll set down the lines. Let's say I have one more class linked list, and I'll create a constructor for it. Now linked list can have just two properties. One is head, which is initially set to none, and then we have tail, which is again set to none. Now if I want to add nodes to a linked list, maybe I can have an insert function which takes a data parameter. Okay, so when we're inserting to the linked list, we'll first check if it's an empty list. So if self.head is none, so if it's an empty list, let me write it as a comment here. So if it's an empty list, what we're going to do is we'll set head as a new list node initialized with the data. And since there's just one element in the linked list, it becomes the tail too by definition. So we'll just set the tail to the head. And if the list is not empty, we'll add the list node after tail, and we'll move tail to the next element. So how that's going to work is we'll say self tail next equals a new list node with data. So now when we were at the end of the linked list, the next was pointing to none. It's now pointing to a new list node. It's not none anymore. But the definition of tail says that the tail should point to none. So I'll just move the tail to next. So it will become self.tail.next. So it's going to become this new list node in which the next is none. So my tail moved one step ahead and I added one element to the list. Okay. Now let's try creating a linked list from an array. Say integer1 array equals, and I'll go back to the problem. So let's start with 2169. And say integer one linked list is a new linked list. Okay, no need for new here, we're doing Python. Now I can just iterate on this array for number in integer one array, or maybe for digit in integer one array. I'll just call the insert method on my integer one linked list, and we'll insert the digit. Okay, at the end I'll just try to print my integer one linked list. Let's run the program again. So what we get in print is an object, because that's just how the print statement works. It will not expand the object for us. It will just print that, okay, there's an object here. So to be able to print the linked list in such a way that we understand it, let's create a helper method, and let's call it print list, which takes a head node which is of type list node. So what this is going to do is it's simply going to iterate on the list node till it reaches the tail. So it will iterate from head to the tail, going next. So while it will be head node. So while head node is not none, you can first print head node dot data, and then we can move head node to its next pointer. Okay, let's try that. So instead of using the print function, we'll use the print list function that we just created. Oh, it threw an error saying linked list object has no attribute data. Okay, because we passed the complete list to it, in order to traverse on the list, we'll be passing only the head pointer of that list. Okay, so now I get 2169 from the linked list. It's giving me a new line, so we can just add end here, set it to blank or maybe a space. Okay, now we get 2169. This garbage value, it can be removed because we're not printing a new line. That's why it's coming in the output. So let's just add a print here. So now we are able to print our linked list the right way. So let's add one more integer, which will be 755. And I'll just copy paste. Do the same thing for integer 2. Let's try to print that. Okay, we have two linked lists now, 2169 and 755. Now we'll come to the core of this solution, which is summing up the two linked lists. So for that, let's create a helper function. Say add link or sum linked lists. And this is going to take the linked list as an argument. So list 1, which is of type linked list, and list 2, which is of type linked list. Okay, it's going to return something. So now we'll be looking at the core of this problem, which is the sum function. So now all we have to do is iterate on these two linked lists and try to add each of the nodes and keep that reference in a third linked list. So for that, we can just write a while loop. So while list1 dot head is not none, or since they can be of different sizes, so we'll have to keep iterating till both of them are exhausted. So just keep iterating till any of the head is not none, whether list 1 or list 2. And I can keep output head here, which will be none. And I also want to keep one ref head, which will be a new list node. We can initialize it with 0. I'll explain why we need a ref head. So when we are iterating on the list, what we have to do is we can say sum equals list1 dot head dot data plus list2 dot head dot data. Okay. Once I have my sum in place, I can check if my output head is none, because that is what I'll be returning from this function. So if output head is none, you set the output head to a new list node of sum, and let's save it somewhere. So if output head is none, we'll set it to the new node. And for the ref head, we'll check if ref head's next is none. If its next is none, is not none. So when ref head has something in its next, so ref head will simply become ref head dot next. We'll move it if its next is not none. And also we'll set the next of ref head to the new node. Okay, let me try to explain that a little. We'll be creating one list node, then another, then one more, then maybe many more. But when we want to return the list, we need to return the first node, which will be saved in our output head. And as I keep adding elements, this ref head will keep moving forward. But initially, since I'm setting the output head to the new node and the next of ref head to new node, so they are pointing to the same thing. And then ref head will keep moving forward and output head will stay there. So we'll have the complete reference in output head. So here, let's return output head. To exhaust this loop, we'll also have to move the linked lists. So if list1 dot head dot next is not none, you move it. So you set the head to head dot next. Similarly, same thing for list2. Okay, let's try to execute it. We have a sum linked list function. Let's call that and pass our integer1 linked list and integer2 linked list to it. Okay, and let's say result head will be whatever that function returns, which we know is a list node, and we'll try to print it using our print list function. So let's run this program. Okay, looks like it's stuck in a loop. It's not returning. Let's debug it. So it's saying if the head is not none or list2 head is not none, and we're setting the head to next if the next is not none. Simply had to check if it exists, then set it to the next. Okay, because otherwise it may never move. Okay, so now it doesn't run into a infinite loop, but we get some error. None type object has no attribute data. So here where we're doing the sum, we are simply using list1 head.data, and when the head is none, it will not have any attribute of data, which is exactly the error here. So to tackle that, let's divide it into two variables. Say list1 value equals list1 head data if list1 dot head is there, else it will be 0. Okay, similarly for list2, its value will be there. Its value will be list2 head dot data if list2 head is not none, else it will be 0. And then sum can be simply list1 value plus list2 value. So that's a small null handler that we have added here. Let's run the program. Okay, so it works. Let's look at the output. I get 2 plus 7 9, 5 plus 1 6, 6 plus 5 11, and then 9 simply gets printed here as 9. So it did something, but we are not exactly at our output. That's because when our sum is greater than 9, we are not carrying forward the extra digit. So for that, maybe we can keep a boolean. Like I've seen people using a carry. We can do that, or we can just keep a boolean, say sum greater than 10, which is false initially. And here when we are doing the sum, we can check if sum is greater than 9, then you can just set the sum to 10 minus sum. It's going to give you the digit. For example, sorry, it will be reversed, sum minus 10. So if we had 11, if we subtract 10 from it, we get 1, which is what we wanted here. So if sum is greater than 9, sum can simply be set to sum minus 10, and we'll also set sum greater than 10 to true, because this value is going to let us know if we have to add 1 to the sum or not. So when we are iterating, we'll first check if sum greater than 10, then sum equals sum plus 1. Also, once we have added the carry forward, we'll set it to false. And then it will again check this condition. Based on this condition, it will either be set to true or not. Okay, let's see how that works out. Okay, better than before. 7 plus 2, 9, 5 plus 1, 6. 6 plus 5 gives us 11. We get 1 here, and 1 gets carried forward. So 9 plus 1 becomes 10. We get 0 here. But what happened to the remaining one? Now we did not add the 5th digit, which is this here. For that, what we can simply do is, currently we are exhausting our loop when the list is ending. In this case, both the lists are traversed, but still we had 1 carry forward. So for that, I'll just add that condition here. So just keep iterating if list 1 is not none, list 2 is not none, or you have a sum greater than 10. So now when we run it, okay, now it adds up pretty well and we get the expected output, 96101. Okay, let's try a few more examples. Say I want to add 5 and 5, should give me a 0, 1. Okay, working as expected. Say I am adding 5, 7, 7 to 5, 1, 5. Okay, so what this is going to give me is 5, 5, 0, 1 will get carry forwarded, 7 to 9. So 0, 9, and then 2, 1. Let's see. Great. So with that, we have completed the program to sum up 2 linked lists. And this is the code in Python. If we look at our sum function, let's see how many lines of code we wrote. 3256, we subtract that. So it's around 33 lines of code, 34 lines of code, and we have a solution. So this kind of question can be twisted. They might give you a linked list which will be in reversed order earlier. Like you might actually get 9612 in the linked list, but then you'll have to add in add the linked list. So the solution for that is very simple. You just reverse the linked list and apply the same sum logic. These questions are also available on LeetCode in different forms, but if you're able to grasp the logic behind what we just did, you'll be able to solve most of them without any problems. If you've made it this far, I'm happy you're one step ahead in your interview preparation. If you liked the video, please share it with your friends so they can also benefit from it. Make sure you subscribe to the channel for more learning videos, and I'll see you in the next one.